Hello class, today we're going to go over Unit 8, Lesson number 4. It's 8.4 Laws of Logarithms. Okay, so instead of just telling you what these new log laws are, I want us to go through a little investigation so you can see where it comes from. So let's start with part A. We are going to get 3 new laws today. It says determine an equivalent expression for log of m times n to the base a. If we know that a, m, and n are positive numbers where a does not equal 1. Okay, remember that's always a restriction. Okay, so the base of log can never be equal to 1. Alright, so a, m, and n are positive numbers. So let's start off. Since a, m, and n are all positive, that means we can write m and n as powers with a base of a. Right? So you can only write, so a positive number can only can be written as another positive number raised to an exponent. Right? Right? It could be ugly numbers, it could be nice numbers, but either way we know that we can write a positive number as a power with a positive base. So we're going to say, let's pretend m is equal to a to the x, right? Some unknown exponent, and n is equal to a to the y, some other unknown exponent. All right. So they want us to focus on an argument that has mn in it. So let's first of all figure out if we were to do m times n, that would be a to the x times a to the y. And based on exponent rules, we would add the exponents here because two powers with the same base were being multiplied. So that means the exponents are added. So that would be a to the x plus y. All right, we've got log of mn. So if we do log of mn to the base a, that means essentially we're subbing, so I'm subbing in mn right here. Okay, so log of a to the x plus y to the base a. So we have to remember the log property that we learned from 8.3, so property number 2 from the other lesson. And that was when they have the same power here, that the answer is just the exponent. So according to property 2, okay, so according to the other log property we know, these two are the same base, so the answer is just going to be the exponent x plus y. Alright, so how can we work with that? The next thing we're going to do is we're going to separate log of m and log of n. Okay, so if I just do log of m to the base a, that would be log of a to the x, right, because we said m was a to the x to the base a. And that's just equal to, right, log property again, that's just equal to x. Okay. If I do log n to the base a, that's log a to the y to the base a. Those two are the same base, so the answer is just y. So how can I relate these two answers, which are these two values, to the log version of them being multiplied? Well, if I take these two values and I add them, then I get this answer up here. So how does that create a log rule? So that means log of m times n to the base a can actually be written as this plus this. So it can be written as log of m to the base a plus log of n to the base a. So when there's a product of something inside the log, you can actually separate them and then add their logs together there. Notice that they have to have the same base. This is your first log law. Okay, so our new log law of the day is this one. All right, let's do the same experiment, kind of little investigation here with log of m divided by n to the base a. So all the same properties, a, m, and n are positive. So just as before, we're going to say that m is equal to a to the x and n is equal to a to the y. Okay. All right, so if I do m divided by n, okay, that is going to be a to the x divided by a to the y. So when we divide powers with the same base, we subtract their exponents. So we get a to the x minus y. So if I try to take log of m divided by n, that means I'm doing, log of a to the x minus y to the base a. property number 2 says if those are the same, then it's equal to the exponent, so it's just equal to x minus y. So it says here, so just so you don't have to rewrite it, we're going to go back up to what we did in this method here. We know log m to the base a is x. We know log n to the base a is y when we set these parameters here. So how do I make these two expressions look like this? Well, that means I subtract them. So if I do this minus this, I will get log of m divided by n to the base a. So we can rewrite this as log of the numerator to the base a minus the log of the denominator to the base a. Make sure you're very consistent with this, that the m is always the numerator and that comes first. Okay. All right, that is your second log law. All right, and our next one, a little different. So we've got the argument is m to the n, so it's a power. Okay, same parameters. This time here, we're just going to say that m is equal to a to the x. Okay, so the same as we've done before. So if I do m to the n, as it says in the argument, that means I'm doing a to the x all raised to the n. So when you have a power to a power, that means you multiply the exponents. So I can write this as a to the xn, right? So x times n. So if I do log of m to the n to the base a, then that's log of a to the xn to the base a. Okay. And those two bases are the same, so the answer is just xn. All right, now I know log of m to the base a is equal to x, right? We've done that in the last few examples. So how do I get this answer to look like this answer? Well, this becomes this if you multiply by n. Okay. So that means, this one's going to be a little different, not adding and subtracting. So that means if you have log of a power, okay, and notice that we're not saying that it's necessarily going to be the same all the time as this one here, but if you have a power here, what you can do is you can actually rewrite log of m to the n to the base a as n times log of m to the base a. Okay, so I always tell students kind of visualize like you bringing the exponent down in front, and then everything else stays the same. Okay. So when you have an exponent in the power, you can bring the exponent down in front and multiply it by the log expression. And that is log law number 3. All right, before we go on to simplifying expressions and evaluating them, so keep in mind the log laws that we just did. Okay, so from the previous page, okay, so coming from the previous page, you can only use those if they have the same bases. So for example, if I give you an expression like this, you can only write it like this as long as those bases are the same. Some other log properties that we should review from the other lessons. Just remember that you have to be careful that you follow the right trend depending on where x and y are located. So here the x is the exponent in terms of this. So when we rewrite it in log form, this is actually going to be log of y to the base a equals x. Because remember, the answer of the exponent is always the argument of log, and then the base of the exponent is always the base of log. So notice here we have another exponential equation, except x and y are switched, so that's why I just want you to be able to work with, I just want to make sure you're able to rearrange to log no matter where the variable is. So remember, now this is the answer of exponential, so now it's going to become the answer of log. So this becomes y equals log of x to the base a. All right, and now those other log properties that we went over last lesson. So we know log x to the base a can actually be evaluated by doing log x divided by log a. Okay. We typically try to resort to that when we can't find a common base. All right, this one, property number 2, we've been working with a lot. So that's log of a to the x to the base a. So when those two bases match, it just equals the exponent of x. When you have log of 1 to the base a, the minute you see 1 in the argument, you know the answer is 0. And if you have log of a to the log of x to the base a, so all that's in the exponent, those are the same, so it just equals the argument, so it's just x. Okay. So now we have all of these amazing log properties and log laws. All right, so let's apply some of those log laws together. Remember, they have to have the same base. All right, so we have to simplify each expression first and then evaluate. So here we can definitely see that we wouldn't be able to easily rewrite 6 as 3 to the something, and we can't write 4.5 as 3 to the something. And we can see they're not base 10, so we can't use a calculator. So that's why I'm telling you here to simplify first using the log laws. So because they have the same base and both logs are being added, that means we can use log law number 1, which is that we can write the two arguments, we can write it as one log expression with the arguments multiplied. So log of 6 times 4.5. Okay, so that little dot there is just a times. Okay, so you can even just write it like this if you'd like. Okay. So log of 6 times 4.5 to the base 3. 6 times 4.5 will give you log 27 to the base 3. And now the next thing you want to do is let's try to rewrite 27 so that we can use this formula here, right? So can we rewrite 27 as 3 to the something? We can write 27 as 3 to the 3. So then we can apply the property right here, okay, property number 2, which says if those two are the same, then the answer is the exponent. So that means the answer to this expression is 3. All right, the next one, we've got log 48 to the base 2 minus log 3 to the base 2. Common base, logs are separated by a minus sign, so that means we can take their arguments and divide them. So it's going to become log 48 divided by 3 to the base 2. That is log 16 to the base 2. So like I said, at this stage here, you can convert to exponential form if you'd like, and then solve how we did it last lesson. Or you can also try rewriting 16 right away as a power with base 2, right? And then you can use property number 2 here. So I'll do a little star. Okay, so at this point, we're going to try doing property number 2 from yesterday. Okay. And that means that if those are the same, then the answer is just the exponent of 4. All right, now we have log the third root of 25 to the base 5. So if I were to rewrite that as out of its radical form, that'd be log 25 to the 1 over 3 to the base 5. Now I'm going to rewrite this as, I'm going to rewrite 25 as 5 squared. So now I have 5 squared to the 1/3, so I'm going to have to multiply those exponents. So I get log of 5 to the 2 over 3 to the base 5. Okay. All right, then I can use that property number 2. Okay. And write that as 2 over 3. If you want, you could also bring the 2 over 3 down to the front. Okay, so you can also do this. Or, okay, you can do 2 over 3 times log of 5 to the base 5, okay, which equals 2 over 3. And whenever this is the same, that means the answer has to be 1. Times 1, and that equals 2 over 3. So as you can see, you're going to notice in this unit that there's kind of like a few methods that you can use to get to an answer. Okay. All right. So now it says we're going to use properties of logs to express this ugly looking expression. So that whole expression is the argument and with the base a in terms of log x to the base a log y base a, and log w base a. So that means we basically wanted, for lack of a better word, we want to kind of dismember this argument into these pieces, okay? Because right now it's all grouped together. So you can see in these examples here, I went from the separated pieces to the combined piece. And now we're going to go in the opposite direction for this question. We have the combined, we're going to go to separated. So the first thing I want to do is get rid of that radical, okay? So I want to rewrite the argument, which is x cubed y squared over w all to the power of 1/2, okay? So getting rid of that square root. Now I'm going to use the property that we just learned before, so log law number 3, where we can take that exponent and bring it down in front. So we can write that as 1/2 times, and then log of x cubed y squared divided by w to the base a. Alright, the next thing I notice is that inside the argument here, we've got x cubed times y squared. So I can rewrite that as their logs added together. And because then it's divided by w, then I can subtract that one afterwards. So I'm using the log laws that say the multiplication means that I can write that as log x cubed to the base a plus log y squared to the base a. And then the minus is because we divide out w. So minus log w to the base a. Alright, so we're getting closer. Now I notice I have another scenario for the log law number 3, which says that if you have an exponent in your argument, you can bring it down in front and multiply. So I'm going to do that with the 3 here and the 2 here. This one just has exponent of 1, so we can leave it. So that is going to look like, so keep that 1/2 on the outside and keep everything still in square brackets. So that's going to be 3 times log x to the base a plus 2 times log y to the base a minus log w to the base a. Alright, so those are as simplified as we're going to get. Now our last step is to distribute the 1/2 into every piece. Okay. So that means we are going to get, so 1/2 times 3, so 3 over 2 log x to the base a, plus 1/2 times 2 is 1, so plus imaginary 1 log y to the base a, and then 1/2 times negative 1, so negative 1/2 log w to the base a. And we have written this all separated in terms of those pieces. Okay, now let's go in the opposite direction here. It says write the following expression as a single log. Alright, so it's in pieces now, and we're going to put it all together. So we have 2 log 8 plus log 9 minus log 36. So the minute that, if I'm trying to piece it together, I know I definitely want to bring any coefficients in front of log up as exponents. So I'm going to bring this 2 up as an exponent to 8. Okay, so log 8 squared plus log 9 minus log 36. Then I want to work with the fact that I know if I'm adding these two together, that means I'm going to take their arguments and multiply them. And then if you want, you can do it kind of all in one. So because then I know I'm going to take that answer and subtract log 36. Again, I notice that they're all log base 10. So that means I can take those arguments multiplied and divide out the 36. Okay. So before we do that, so I just did 8 squared as 64. So now we can do 64, so log of 64 times 9 divided by 36. So you can write it like that. 64 times 9 divided by 36. Alright, when you enter that into a calculator, you are going to get log of 16. So again, it's common log. So if I asked you to evaluate this, I know I didn't, but if I said simplify and then evaluate, there are 2 things you can do. Okay? First one is you can use the log law that says you do log of the argument divided by log of the base. So log 16 divided by log 10 gives us 1.2. Or because you may notice that this is a common log, so you can actually use your calculator. Okay, so you can use your log button on a calculator, do log 16, and you would get 1.2. Okay. So this 2 would equal 1.2. Alright, and let's turn over. Okay, so our last example here, it says use the laws of log to express each side of the equation as a single log, and then once you've done that, then you can solve. Okay. So just at the side here, I've written some laws that, or some rules that will help us with solving this problem. So remember, when you have two exponential expressions equal to each other with the same base, it means their exponents are equal. And the same rule kind of applies with logs. So if you have log of m to the base a equal to log of n to the base a, the only way two logs with the same base can be equal to each other is if their arguments are equal to each other. Okay. All right, so that means this has to be equal to this in order for that statement to be true. All right, so let's work with the left side and the right side and writing it as a single log. So we've got log x to the base 5 minus log 8 to the base 5, and then we've got log 6 to the base 5 plus 3 log 2 to the base 5. So like I said, whenever you see a coefficient in front of a log expression, good idea to raise it up as the power, as the exponent to the argument. So right here, I brought this up so it was log 2 cubed, right? 2 to the 3 to the base 5. On the left side here, I noticed they had the same base. They were being subtracted, so that means I can take their arguments and divide them. So it becomes log x divided by 8 to the base 5. All right, now I want to evaluate 2 to the 3. Okay, so everything stays the same, and then I'm just writing that as log of 8 to the base 5. I can see that these two have the same base, and both logs being added, so I can take their arguments and multiply them. So log x over 8 to the base 5 equals log of 6 times 8 to the base 5. Okay. Again, if you want, you can write it like this. That dot, remember, just means multiply, so if you want, you can do double brackets and then just kind of show the two sets of numbers here if that visually looks better for you. So log of 6 times 8. So we know that's log of 48 to the base 5. So this is where this rule is going to come into play. Okay. Log of something to the base 5 is told to be equal to log of 48 to the base 5. The only way these two can be equal with the same base is if their arguments are equal. So that means x over 8 has to be equal to 48. So that's what you're going to say in the next line. So x over 8 must be equal to 48. You're going to cross multiply. And x equals 8 times 48, which is 384. So we simplified both sides as a single log. And then we used our properties, or some logic there with math, knowing that that's the only way these two could be equal to each other, okay, to find that x was 384. And we did all of that without essentially having to go through any systematic trial or any complicated process. And this is how log laws are beneficial in simplifying expressions. All right, that's it for this lesson, which is nice. So just remember how your exponent laws correlate with the log laws. So if you want, you can just call them log law 1, 2, and 3, or you can call it the product law, the quotient law, and also this one should be the exponent law, okay? Or the power law. So let me just change that there. Just change that to the power law, okay? So you can refer to it as that, or log law number 1, 2, or 3, okay? So remember, whatever the exponent is, so for example in this form they have the exponent being r, r can come down and be multiplied by log. And all of these can only be used if you have the same base. Okay, so make sure you check that. I know in the homework it might be more obvious, but later on when we go through a bunch of questions like this, a common mistake is that students use a log law when the bases are not the same. All right, I hope you enjoy doing the homework, and let me know if you have any questions. Okay, good luck.